Good afternoon. My name is Ron Land, and my job is to moderate this last panel, and maybe an important part of that job is to get us out of here on time. So I'd like to go ahead and get us started. Again, we have an impressive panel of people up here, and the topic for this panel is on the screen, government and industry roles in employing engineering technology graduates. Let me take a few moments to introduce our panel. Let me start at the far side. Dr. Richard Voyles. Dr. Voyles currently is the Associate Dean for Research in the College of Technology at Purdue, and he's also the founding director of the Purdue Robotics Accelerator. Recently, and as I understand again in not too distant future, he was an advisor on the Office of Science and Technology Policy at the White House, where he was the assistant director of the Robotics and Cyber Physical Systems program. While he was there, he was instrumental in the expansion of the DARPA Robotics Challenge as an international cooperation, and he also advocated for the increased funding for robotics and CPS research and pushed for filling the gaps in the educational continuum from HS to MS, and particularly including engineering technology as part of that. Prior to his involvement with the Office of Science and Technology Policy, Dr. Voyles was the lead program director at the National Science Foundation running the National Robotics Initiative. In the middle, if I get my papers right, should never staple things together. In the middle is Mr. Kyle Stott. Kyle is the operating engineer manager for Siemens Industries' Large Drives North America division. Kyle started his career with GE, where he joined in their engineering leadership development program, and from GE he went to Siemens. At Siemens, his leadership skills, experience, and creativity has resulted in the development of new products, new applications, new operational methods, new reliability analysis, and system design processes for the transportation and industry sectors. He's co-authored several patents and currently develops global teams to enhance the delivery of products and services to Siemens customers. Kyle at Siemens also coordinates the Early Career Engineering Leadership Program for new Siemens engineers. He's both mentor and functional engineering manager. He recruits, hires, and develops engineering talent in multiple disciplines and at various levels. And finally, just to my left, I have the right piece of paper. This is Dr. Martin Reed, and Dr. Reed is currently the Senior Project Executive with IBM Global Services, where he is responsible for managing systems integration contracts with federal agencies. In that capacity, he leads teams of software architects, engineers, business analysts, project managers, trainers, and operations staff in supporting clients' mission-critical business systems. He's a member of Project Management Institute and holds PMP certification, and he's also a member of the IBM North American Project Management Certification Board. He's a longtime volunteer with the IEEE, supporting engineering technology accreditation activities with the Engineering Technology Accreditation Commission, both as a program evaluator and as a commissioner. He also serves on the Information Technology Industrial Advisory Committee in the School of Business and Technology at Excelsior College. Dr. Reed also holds U.S. patents on text and image processing and device management, and has published articles on data communication, computer graphics, and technical education, and has served as an inviter referee for journal articles on data communication and text processing. So I think we have, again, another exemplary panel. I'd like each of you to take 2 or 3 minutes, tell us a little bit about what you're doing in your background, and then we'll get to questions. So let me start with you.
Okay. Thanks, Ron. So, as Ron said, I work for IBM. I've been with IBM for 40 years, my entire career, straight out of college. But the good thing about a large corporation, large global corporation, is that you have the opportunity to do different things and advance your career along the way. So that's, so here we are, 40 years later, and I've had great experiences. As many engineers or engineering technology grads find, as time goes on, you tend to, sort of rise to a level of experience and confidence among your managers, your peers, your superiors. That often leads to management, which was the path that I took. And so it brought me to where I am now, running federal IT programs. that support our, as Ron said, our mission critical systems. I have been involved with accreditation for many years. I'm really interested and passionate about supporting that activity. You know, as we go through this panel, I'll talk a little bit about the areas that I particularly focus on. My own degrees are in engineering. So I've picked those up, you know, over the years. I also have a degree in operations research that I picked up part-time. Senior member of IEEE, and yeah, that's what's led me to this day.
Thank you, Dr. Reed. My name is Kyle Stott, and I'd like to thank the ASCE as well as Professor Land for having me here today. I hope I'm as lucky as you to have as much industry experience. I don't know if I'll make it that long sometimes, but thanks again for everybody for having me. I'm here today to speak as a voice from industry. Through my career, and like Dr. Reed said, I've been lucky enough to experience a wide variety of activities as an engineer and engineering leader. One of those is developing corporate engineering relationships with local higher education institutions. I have a BSE from Gannon University in Erie, Pennsylvania, and that first relationship started with GE Transportation as I worked as a co-op there. From there, I got to recruit for General Electric to Penn State University, and most of that was Penn State, Maine, and corporate recruiting was the focus of the main campus recruiting. But then on my move to Siemens, ended up on Penn State's regional campus in New Kensington, ran into Professor Land here, and started to develop a relationship there. So now with my local Siemens business, I have a relationship where I first got my experience with ET graduates at the branch campus of Penn State. So that's been something that I've been fortunate enough to be able to do through that diverse experience in large corporations. I've also worked with your graduates very, very closely as entry-level engineering development programs leader at both GE and Siemens that take rotational experiences and expose graduates to that first level, their first exposure to engineering work, as well as doing continuing education coursework for master's degree pursuits. One of the third things that we tried to introduce, or hopefully not introduce for the first time, was team-based work, which was something that you see different levels of capability with new graduates. Another point that I hope to be able to bring to the panel is global team development. Through my career as an engineer and as a leader, I work with teams from India, China, and now Germany on either joint designs or share common designs in regional markets. And then finally, the functional team development aspect of that for local and global teams, developing talent pipelines from the very beginning and identifying talent to fill the next generation. So looking forward to the discussion.
All right, well, I'm kind of described as the government guy in some sense, but I've had kind of an unusual career. I started out in industry and worked for several years after getting my bachelor's in engineering as an industry guy. Went on to get my master's and PhD, all three at different institutions, and have held tenured positions in both computer science and engineering departments. I've spent 3.5 years at the National Science Foundation, and then more recently at Office of Science Technology Policy at the White House, as mentioned, and had the opportunity in seeing all that, and my views have evolved quite a bit at where, and I think they starkly contrast our esteemed colleagues from the societies on where engineering technology fits in. And so I actually switched from engineering to College of Technology at Purdue because I think it represents a really exciting opportunity. That I think in having this pathways of what I've done, and particularly more recently at NSF and at again these multiple universities, that's what I want to talk about today, and in the opportunities in workforce development that I think there are just some things that that resulted partly from Vannevar Bush's, Endless Frontiers document in 1945 that didn't put us on a wrong path, certainly. But I think switched paths, and I think both paths are valid, and that's an important part, I think, of some of what's lacking in our workforce development today when I talk about, from HS to MS, from high school to on grad school and beyond. And that's what I've been kind of invited back to the White House to further that interest in how we fill the gaps between this plethora of programs that we really have at our disposal for the betterment of STEM education and our society as we move forward.
Thank you. Turns out that's a good segue to my first prepared question. Maybe you planned it that way. One of the characteristics of this panel, I think that may be a little different than the other two panels, is we have three gentlemen here who have experience both with engineering and engineering technology graduates. And so it gives me the opportunity to ask some questions I think many of us would like to hear. One of those questions is, because of that experience with both groups of graduates, what I would like to ask each of you to do is spend a few minutes discussing what you see the specific skill sets and capabilities, and compare and contrast those among the two groups, and particularly how those kind of things might influence hiring policies at your company or task assignments to employees, and the experience between the two groups of students as to how that works out. So how about we start with you, since you've...
I'm going to defer to these guys since they're the industry guys.
Okay. All right.
And then I'll follow up
With the right answer.
with a government perspective.
My experience, Professor, is it's varied, of course, just like the candidates that come to me. My early experience with ET graduates, and I think this is something for managers of my current generation of managers, let's say, is that that associate program, that association, that engineering technology is an associate's degree program, is a hindrance to ET graduates even getting interviewed in the marketplace. And that was certainly my very early on experience. With the corporate recruiting today, I know from at least these two experiences in corporations that the corporate recruiters and these companies are not recruiting ET graduates because it's that perception and that lack of understanding of what ET is versus what engineering is. I've had direct conversations with corporate recruiting coordinators and asked specific questions about recruiting ET graduates because of now my recent experience with the capabilities of ET graduates. And it's very clear to me that they don't understand the capabilities. Through my personal experiences and the local experiences that I've had with ET graduates, I've found them to be highly applicable to the work that I do. So the work that we currently do is in medium voltage drives production, heavy industry, and manufacturing. So it's design and manufacturing. Specifically, my group does applications work, and these individuals, I have about 7 of them on my team, out of a team of about 60 people, and they're exactly the type of talent that I need. And in my own ignorance, a few years ago, before even knowing that, I said, is that an engineering degree or what is that, And thankfully, I've been able to find out exactly what it is and how capable the graduates of these types of programs are, because they're a huge asset to me. On the engineering spectrum, I also have experience with engineers. Like I said, General Electric, they only recruited, at least in my division, they only recruited engineers. And what I found is that they're also highly flexible individuals. But you need to understand from those individuals whether they want to pursue the theoretical route or the applied route. And did most of the work in heavy industry with General Electric in both their drives division and their locomotive division, most of that work was applied work. There was a little bit of a simulation analysis at the concept phase to determine if this was a good way to go. Detailed design phase would enter, but most of the true theoretical proofs came out really in testing. And we did rely on some graduate and PhD level engineering at times, but again, it was typically the professors from the local colleges that we would rely on for that type of skill set. So we found that that more of that applied more of that applied engineering approach was more applicable to what we were doing on a day-to-day basis in the production of heavy equipment.
So I'll talk a little bit about my experience with technology, grads and technology background, although I have to say, then I'll kind of compare that to what I do today and the environment that we're in today. So, you know, when I was in college and had summer jobs, it was typically in a role that I think might be characterized as a technology role, doing things like electronics assembly, for example. So I did that for a private company. I had a government job that involved something similar to that. And my colleagues at the time, as well as the role I was playing, was for a technologist. So in this case, someone who would take instruction and then repeat it multiple times, and I think did a really good job at that. And I felt the same way about my colleagues. Then you start to move into, you know, when I had my full-time job and the experiences I had both interacting with hiring or overseeing the hiring of staff that likely had technology degrees. This would be for things like technical support staff, desk side support, PC repair, network engineers, facilities staff, people who did things like cabling of offices or of facilities, that type of thing. So I've had experiences working with hiring or overseeing the hiring of staff like that. So let's move forward a little bit to today and you know what I see as we bring in graduates from engineering or engineering technology programs. And to be honest, I don't really differentiate between the two. Part of what I look at when I evaluate candidates is skill set. And this starts with what's on paper, right, in the resume or the job application. Skills that they've performed, skills that they can tout on their resume, understanding of current technologies, current tool sets. All that's important. Do I look for the educational background and the degree? Absolutely. And depending on the role I'm asking them to fill, which could be in response to a need we've gotten from our customer, right, for a certain task or skill that has to be filled by someone with a prescribed labor category. And sometimes that labor category will call out the qualifications of the people who we bring in to fill the role. So I have to be cognizant of those types of things. But generally, when I look at bachelor's degree in a related field, whether it's engineering, engineering technology, or something similar to that, it really makes no difference to me. Part of the reason for that is that, as I think you know, we were just talking about, IBM is also a global company, and we source staff from around the world, not just in the local countries, but often as people come to the U.S., we source people for these roles who have degrees from institutions outside the U.S. And in that case, you get a much broader diversity of the names of the programs. A number of our staff on the contract I'm running today are from India originally. One of the reasons is that unlike some government agencies up until now, we've allowed non-U.S. citizens to be staffed on the contract. So we have, you know, and of course India is a tremendous source of technical talent. And sometimes the institutions or the programs are called bachelors of technology. And that's perfectly fine because, again, what I look at are skills, and I look at experiences, and I look at characteristics. So the one other thing I was going to mention is, and we'll get into this more later, the characteristics I look at, many of them, and this is also advice I can provide, and it's part of the reason why I've stayed so involved in ABET accreditation, is I think if you look at student outcomes in the A through K, the 3A through K, many of those, in fact, are really important in the workforce. Clearly, the technologies and the coursework and the background students bring in is kind of a given. but the ability to communicate, the ability for teamwork, the ability to have integrating experiences, for example, which are often prescribed in the criteria, appreciation for diversity. Things like that are really critical in the workforce because everyone works as part of a team. They have colleagues, they have subordinates, they'll have superiors, they have customers, they have suppliers of service that they're providing. So characteristics like that, initiative, commitment to lifelong learning, right? Because in our field, things change so frequently that we are counting on staff to be self-motivated to stay current with technology, to have learned how to learn, and to be motivated to learn. So those are some of the things I look at when we staff.
So I'm not going to compare directly engineering technology and engineering graduates. Instead, I'm going to compare a little bit about ourselves through analogy. An experience I had at NSF was in the Innovation Core program. So I was one of the founding program directors that created the Innovation Core program, which is a program basically on entrepreneurship. And the reason we created this is because, for many decades, we started to have this, of course, after the shift in 1945 and actually 1950, when NSF was created as a result of Vannevar Bush's paper, Science, the Endless Frontier, we started to put federal funding into research and development. But we didn't have any real meaningful programs on tech transfer. And so in the 70s, those discussions started to come up as, well, wait a minute, we're really pumping a lot of money into R&D that is either being duplicated in industry or is not making it into the national ecosystem. And at the same time, we were thinking about entrepreneurship in general and small businesses and how do we encourage small businesses. Because it was recognized as really the linchpin for the U.S. economy and how the U.S. economy had really grown with respect to the world economy and its importance. And so naturally, as engineers, one of the things we started to do was say, okay, let's solve this problem. And we brought in the business schools and said, how are we going to teach, to create and nurture small business? And more entrepreneurship. And I think Harvard is kind of credited with one of the first entrepreneurial engineering programs in the late 70s. They really started to become popular in the 80s with this thrust on, building a business plan, learning about IP, learning about, what it takes to build a nice, successful small business. Because at the time, startup success was about 10%. So in the United States, roughly 10% of our small businesses was what drove the economy, created jobs, all those things we're talking about still now. So it's been 30 years, and we were sitting around NSF saying, okay, well, how successful have these programs been? And a natural question is, well, what's the startup success rate now? After 30 years of entrepreneurial engineering, 10%. It's exactly the same. And in fact, if you look at, I've got some wonderful charts that I'd love to share with you on if you look at all the quantifiable metrics, pretty much all of the quantifiable metrics you can come up with on innovation, they all have a downward trend since this time period of the 1980s. The number of startups, the percent of people working at startups, the amount that they switch, a whole bunch of metrics are not terribly positive. And so we looked at it from a different perspective. Okay, well, and what the conclusion we came to was the business schools had driven a good program for small business. But startups are not small business. They're different, actually. And that's our conclusion. And so there's this increasing movement toward the customer discovery process and the business plan canvas and the fact that it's really a startup is a search for a business plan. And so that's kind of what what the innovation core grew out of. Now, what's the analogy here to ET and engineering and engineering technology? These are opportunities. It's not that the small business is not important, that growing and maintaining small businesses is not important to the United States economy. It is. But startups are different. And I think the same thing, and they're both valuable. You can't have small business unless you have startups. And so these things are complementary. They work hand in hand. I think the same thing can be true of the shift, right, from pre-war to post-war. When we went to more theoretical programs, largely it's acknowledged that Vannevar Bush's document, wonderful as it is, because I wouldn't have a job at NSF if it weren't for that document, wasn't a scientific research document, right? It was a political statement to say, hey, we have to invest in R&D. And it made this kind of arbitrary distinction between applied research and basic research, which a lot of the studies now, when we actually look at it, don't support some of the things that were brought forth in this document. Again, the point is, the analogy being, like small business and startups, the engineering and engineering technology programs, I think, are complementary. I think they address different things, and we can make the exact same observations of engineering today. I've been, like I said, I've been in a computer science department in a land-grant institution, an computer engineering department in a small private institution, and there is an area, a niche that engineering, and I'm proud of my engineering heritage, by the way, but we seem to have also, if you just look back at our history, we've been stuck on the same niche of people we've been drawing. And I think engineering technology is actually a complementary view to maybe expand that a little bit. The participation of women and underrepresented minorities in engineering, we've been really trying to solve this problem for a long time and haven't been very successful. The numbers are actually going down that I've seen more recently. So I think there is, similar to, again, it's not a question of what's good and what's bad. It's a question of how do we expand the pool of people we can attract and draw to when all of our occupations, our livelihoods, are increasingly engaged in technology and engineering and math and science. And I think that the evidence is very clear that our engineering programs, as they are the most revered in the world. They're good at what they do. But we need to broaden, and we've been unable to broaden them as much as I think we need to. That is, I think, an opportunity. I think that's a real opportunity for our professional societies, right? In broadening that, because there are different ways to do it. I don't think we should just cram everything into engineering and to eliminate the confusion, because I'm not sure with the broadening of the technology field, I think we are in fact broadening the opportunities, and that means I think we need to broaden all of our available programs, which includes things like engineering technology, and lauding the distinctions between these, right? To try to achieve, just like that effectively kind of happened with the separation in a conceptual way of Vannevar Bush's approach of, well, okay, we kind of shifted almost entirely from this more applied view to a research view. We just need to swing back to include all, I think. And that's why I've been focused a lot on this workforce development problem. And one of the issues specifically is around manufacturing. Because we're talking about reshoring jobs, we're talking about the reshoring manufacturing jobs, yet we've been shedding 5 million out of 17 million manufacturing jobs in the last 20 years. But we're still, believe it or not, China is not the world's largest manufacturer. The United States is. While we were shedding those jobs, our manufacturing volume was continuously going up because we were focusing on highly productive jobs. But when you're talking about a manufacturing job, there's this huge pyramid, right? From the theoretical design engineer, right, which may be creating some specific new project or product, to all of the various capabilities that are required to actually produce that. And the depth and the combination of breadth and depth of expertise that's required that is getting so much more diverse that I'm not sure it fits in engineering anymore, at least not by our traditional definitions. And so I look at this as this tremendous opportunity to deal with the increasing need for STEM graduates across what is a continuously expanding expertise demand.
Okay, thank you. I think based on your comments, I'm going to change my second question. The question was going to be based on the first answer, what we might do to make our students better prepared for the kind of tasks that you have them perform. I think based on these answers, I was impressed by the fact that Marty has gotten to the point where the title is not particularly an issue for him. Kyle's had the experience that I think most of us are aware of, that large engineering firms, many times they only think engineering. I know from another activity that we've been involved in that the federal government has that same problem. So I guess the question I would like to ask is, what can we do in academia to better educate companies, or at least to get them thinking about this broader spectrum that you mentioned? What can we do to help have that happen?
Let me start with that, because I think one thing we can do is just look around the world and see what other countries are doing. And the evidence that there is this fine complementary duality, I think, exists in most other countries. And the most obvious example is Germany, right, where they have Max Planck institutes and they have their Fraunhofer institutes, which clearly have these different approaches. One is much more science-y type of theoretical, but still involves industry and involves the sciences and engineering. The other is a lot more applied. And if you look at the percentage of the undergraduate student body that is represented, right, you see that in fact, we're kind of stuck at this 4% level when you consider engineering and computer science. And I lump computer science in there because, it's hard to even draw a line between computer engineering and computer science. And so I throw that in there. And it's about 4%. If you look at Germany, it's more like 12%, and France is in that 12 to 14%. China is more like 35%. It's harder to tell what those numbers mean in China, of course. India, I think, is the same way. That they have a broader definition, right, of what engineering is, because it includes things like Fraunhofer Institutes and Max Planck Institutes, for example. And so I think those are things that, we can look at and try to emulate.
I like the broadness of it, the comment that you made. I get a little bit concerned about dividing up R&D engineering versus applied engineering. In General Electric, the model was you were an engineer and you were part of the engineering group, and you could be working on an applied problem one day, a reliability problem in the field, and probably usually concurrently you're working on a development project, which as an engineer got a little bit stressful. But now in the Siemens company, the Siemens model is to split up the R&D and the applied piece. And the only concern that I have of it, I appreciate the definition and the roles that are in those two, but the only concern that I have is that we get locked into, well, innovation can only come from the engineered side. And I see that a little bit in Siemens sometimes, where there's a stratification of, well, innovation comes from the R&D guys and the applied guys are just doing customer orders. And if we can address that challenge, I think having the broadness of the engineering discipline include all of those things is a good thing. We just want to make sure it's inclusive as well to take the best ideas from around that broad spectrum. So I also think the other benefit of the technology problem is the accessibility. I think the benefit of the engineering technology degree is the accessibility that it brings to education. So students that are on the fence about whether they want to go the business route, the management route, or if they want to go the engineering route or technology route, this is a way to say it's more tangible to them, or especially early on in their education, to say this is an accessible career path for you, this is an accessible education path. Even if you're not totally sold on you want to be the theoretical mathematician, I like that aspect of the technology program, so I would recommend that we keep that up. From my experience, I've also seen a great focus on the use of tools. The technologists that are generated out of these programs, I feel, have an excellent grasp of tools, and I would say keep the focus on tools like this, because that can bridge the gap between some of the theoretical education that's not taught in these programs, and it allows those engineering technology graduates to actually produce a higher level of work without going through the fundamental behind the scenes math. I mean, it's very infrequent that I ask my engineers to do pages and pages of derivative equations in their work, but through the tools they can get the same result, and with the fundamentals they can actually verify that those results are accurate. And kind of to further on to that point, I would say adding in simulation capabilities to the use of those tools is something that would further enhance the capabilities, and I know some programs are already doing that. But the simulation capabilities, I mean, for an employer translates to lower costs. Usually in industry, what we're doing is we're validating the simulation results in the lab as well. So you're combining both your theoretical, your simulation, and actual true validation in the field. And it's validating the concepts that these students have produced. So, and so on the other side of things, what would I like to see enhanced in the program? Design process a little bit. The engineer technologist seems to have a tendency to be the one to get things done. And that's what we love about them, right? Get your hands dirty, get the bloody knuckles, and get things done. My experience has been that they also tend to jump into detail design. And I think as educators in engineering technology, I'd ask of you to make sure that design process is very clear from the requirements management side, conceptual design, then the detail design, test planning and test results, and I'd throw simulation in there as well. And just an idea that I'll throw out on the table was something that came from the global discussion today. A lot of the technology programs I'm understanding, or at least I'm observing, is through a branch campus model. And I would say use that to your advantage to teach how to work within global teams and distributed teams. And use that to do remote learning experiences. I think you're set up for it the way that you have it right now, and it'd be a way to get students familiar with those things.
So on this point about, educating the employers, I think that's sort of a two-way street, right? Because I think it's really important to look at what do the employers need, and then what do the programs need to do to satisfy that need. So, one of the areas that I think could take some more focus is the industrial advisory boards, right? I've been out on accreditation visits many times, sat in on every one of the meetings we have with the industrial advisory boards, and that's a requirement, and it's good that there's participation. But, it tends to be dependent upon the individual and their interest in helping the program continue to develop their educational objectives, student outcomes, curriculum changes, things like that. It seems like, in my experience, I mean, the tighter we can make that partnership, and this is a hard thing to do on both parties, right? But the tighter you can make that partnership, the more successful you're going to have in expectations of the student, what they take out of their experience on campus as they move to employment. I'll give you one example. I'm not directly involved in this, but I'm aware of the program. There's a program started up a few years ago called P-TECH, Pathways in, sorry, I have to look at my notes, Technology, Early College, High School. It's a program that is a partnership, in our case, between IBM, public schools, and colleges. So one example of this is in New York City. City College of New York has a partnership with IBM and with high schools in New York City to provide what they call a 6-year degree. The last 4 years of high school and 2 years of effectively college-level courses that end with the students getting an associate's degree in engineering technology, computing, some discipline. And by the way, along the way, having had internship experiences, in this case at IBM, and when they graduate, having sort of the priority at least to compete for jobs, right? So they will be interviewed. Whether they're selected or not is, dependent on the jobs and the pool of applicants and so on. But they will get priority for interviews for jobs in that area. And that seems like a great model for how we tightly connect the content of the program, experiences along the way, internships, and frankly, even tuning the programs, the coursework, the experiences to provide that smooth flow into employment for, in this case, associate graduates. So it's a very interesting model, I think. It's been replicated at, I believe, City of Chicago has done something. There's a city in Norwalk, I think Norwalk, Connecticut, that's tried this as well. So that's along the lines of what I'm talking about. How do we more tightly integrate the employers with the programs, right, so that we have that smooth flow for students?
Ron, can I interject one other thing? I want to magnify some of the comments that Kyle in particular made, but also I think Marty on, this division between research and basic research and applied research is actually my main beef with the 1945 document, because it set up this artificial view that basic research led into applied research, which led into development, which led to commercialization. That was the justification that government should be spending money on basic research. Again, that was an idea that wasn't based on research or study. I think what's now acknowledged is that basic research and what we're now calling basic research and applied research, or what we're now calling use-inspired research through things like Pasteur's quadrant, are actually different pathways into new ideas that lead to development and commercialization. And again, the basic models, we talk about, the Bohr approach, which is just, basic knowledge, the Edison approach, which was just solving a problem, and then Pasteur's quadrant is this, it was this search for knowledge, but with a defined end. And those things are actually different, and it's important that they are equally important to the socioeconomic benefit of really the country.
Okay, thank you. We've had some discussion earlier today, and one of the questions I prepared for you guys is this issue with professional registration. It's a common question from our students. What's the importance of professional registration? When is it necessary? When is it simply an option? The problem is particularly important for ET graduates in about a quarter of the states, because they're not even eligible to sit for registration. So I guess if you could spend a few moments talking about just how important you see that being, both in your company and maybe in general. Is it critical? Is it optional? What are the advantages, disadvantages, so forth?
So from my direct experience, professional registration is really not important at all. The jobs that we hire people for, and maybe we're in the minority on this, don't, typically require or even prefer professional registration. What we do value, though, are certifications. So when we're bringing on staff, depending on the discipline that they're in, so I'll pick mine, for example, in project management. So having PMI certifications or something more typical these days of Agile certifications for things like Scrum Masters. It's really important. If we find that would be a differentiator between people who have otherwise equal qualifications. In technology, there are things like Microsoft certified systems engineers or certified Cisco network engineers. Those types of certifications are important because they're directly applicable to the jobs that we're asking people to do on day one. So that tends to be what we look at more so. There are also examples in areas like information security. This is an important topic now. Cybersecurity is critical for all of us. We're all aware of what's happening in the world and the threats that are present. So we have a staff that pays attention to this, and they typically have certifications of things like, if I can get the acronym right, CISSP, Certified Information System Security Professional. But that having that credential and then having experience that again we can directly apply as the graduates come in and we slot them into jobs. That's where we value certifications.
I really like this idea of yours of certifications. It really helps to understand where people are passionate about to take that extra step to go after a certification. That's one of the things hiring early career individuals, it's sometimes difficult, especially if they don't have internship experience, to figure out exactly what pathway they're really passionate about when it comes to technology. In relation to the specific question, I've done work in drives, controls, locomotives, off-highway trucks, mining, marine applications, power gen, oil and gas, and then the municipality and wastewater industries, and have had a very small need overall for the professional, the PE license. And the reason for that is that as a manufacturer of components and systems, we're not doing the site integration. So it's the site integration people that we rely on for the PE certificates to actually do that type of work. There's, I would say, the overall represented population, the number I heard of about 15% of people that go pursue licensure, I would say that represents my experience with the corporations and about the percentage of people that have it in larger corporations. But in terms of the specific requirements for the job, it's not generally required. It does help on certain instances, and my experience has been corporations will fund individuals to go after that licensure as a individual side task on their own to go pursue it. So they see it relevant to the job, but they don't see it necessary for the job. And I think it does help. My experience has been that it helps for being able to determine requirements in terms of site requirements, in terms of how these products will be installed, how to interpret requirements from the civil side of systems integration on site, and it does help them for the job. So I think that's why you see the tendency from industry to say, well, if you want it, we'll fund your effort, but it'll be on your own time, type of thing. So that's I think with the data that was presented earlier on licensure, is very good and accurate and describes the experience that I've had in the industry.
Yeah, I think the whole question of licensure is actually a bigger confusion, a much bigger confusion than this question of what is engineering and engineering technology, because we call ourselves a profession, but anybody can call themselves an engineer, and that's a bit of a problem, really. And so by the strict definition, we're not really a profession, right? Because as I think the comment from IEEE was 15%, right, of the membership is actually registered. And yeah, I mean, it's not, there are some engineering disciplines that really do require effective to do your job require a PE license, but the vast majority of us don't, and so clearly it's it is driven by the specific discipline, but and I'm not clear what the appropriate solution here is. Do you say, okay, well, everything should require a PE so we can then kind of end that confusion, or not? I don't really think so. I think there's an odd exclusivity that has resulted in engineering that I'm not sure is good or bad either. So I don't have, I guess I don't have much of a solution here, but it is a conundrum.
I do think the fundamental principles of the licensure is something that everybody in the profession should want to pursue. You know, being able to demonstrate that you've mastered the topics and and that you have the applicable practice and the character and the ethics behind what we do, because it does impact people on a social level. What we do, I think that's something everybody would want to pursue. The licensure itself, though, is I think a different issue for employers.
Okay. All right, you guys may be catching on to the fact that my questions are really questions I need to answer myself for people. So I'm going to finish my questions with another one that comes up often for me, and that is prospective students and their parents routinely ask, whether they do or not, they think they know engineering degree means something, and they want to know what engineering technology means. And I guess the question in general is, how would you answer that question to a parent that said to you, describe for me the difference between an engineering degree in mechanical engineering and an engineering technology degree in mechanical engineering? So help me out.
You want me to take a stab at that, or do you want to go, Marty?
So let me start this off, and then we'll go from there. So, you know, if I were in that position, you know, I think I would again try to turn this around and ask, you know, what the student, I mean, is interested in and what they want to do with their career. When we bring people in, generally, we hire for careers, not for specific jobs, which means we look for the skills they have today. Obviously, there's a job we're hiring them for, but it's the capability to grow over time, right? That they have the, you know, the characteristics, the drive, the interest in continuing to learn, to advance themselves, to take on potentially more. It's one of the ways actually that we differentiate between jobs, between entry-level jobs and more senior jobs, is characteristics of performing a job versus prioritizing tasks versus leading tasks, for example. So that's what I would start with. What are you interested in doing? Do you think you want to you know, learn a given task, a given set of trades, set of activities, and that's what you want to continue to do and do it very well? Are you interested in potentially going to graduate school someday? And how might the work you do now and the academics lead you towards that goal? So I'd put it more in terms of the types of work and where you see yourself in 5 or 10 years than necessarily differentiating between the two. Because again, as an employer, the difference between the two doesn't really matter that much to me.
Let me go. Okay, so that was a high-level answer, but had some various. And I'm gonna go even higher, maybe. Because I think that's an important answer. But I look at this as you know, what is science and what is engineering and what is technology? I think we know what math is, right? I think people have this crisp view of kind of what math is. I think a pretty good view of what science is, pretty good view of engineering. We haven't really defined what the T is in STEM. And my high-level description is this, that science is the discovery of new knowledge, that engineering is the creation of new artifacts and processes, and technology is the implementation of new solutions. And all of us do all of that, right? It's just that in the sciences, they tend more to the discovery, and less on, more to the new knowledge, less on the artifacts, less on the solutions, right? And I think engineering is in the middle where, yep, there's some discovery of new knowledge, there's some implementation of solutions, but there's there's a focus on the artifacts and the processes in between, and likewise with technology. And an anecdote, right, that I still remember from the 80s, sitting as an undergraduate engineer was this is back in the days that many of us, I'm sure, remember, Greyhound buses driving around. And one of my professors, from Purdue, in fact, told us about this great project for he had designed these a chin spoiler and eyebrow spoiler for Greyhound buses that was going to save Greyhound $4 million a year, and this was going to save Greyhound, right? This was a solution. And I remember sitting in that class as a sophomore thinking, I have never seen a Greyhound bus that looked like that. It had that simple eyebrow spoiler and chin spoiler, which get dramatic improvement in fuel efficiency. And the point is that he had created an artifact, not a solution, because he hadn't done the breadth of study really required for not just the creation of an artifact that increased the aerodynamics of the bus, but what about the manufacturing costs? What about the maintenance costs? What about the costs? And all these other pieces that I think go into creating a real solution. And that's where I think that those three disciplines kind of overlap, just in various, how you balance the pieces of the equation.
Another question?
Oh, you don't want no, you don't have to. There's no obligation to answer every question.
I've got a little bit of a follow-on.
All right. Yeah.
No,
See, he bailed you out.
No, I do have some comments. I thought you were going to add on to that for a second. In U.S.-based firms, I do believe that the career is engineering. I think that's an articulate way to put it. But I also agreed with the earlier comments from today with Mr. Pearson, saying that we don't want to be in competition with the engineering programs. The ET programs don't want to be in competition with the ET programs. So trying to make that distinction without being in competition is a fine line to walk. So I would, again, embrace that accessibility of the benefits of the ET program to people that are problem solvers but don't know if they're true fundamental math lovers yet. Try to instill that throughout the program, but allow it as an accessible way to get into the program. I would highlight the applied aspects of it. I think you can talk in a very interesting way to high school students about what applied engineering or applied technology means, because it's stuff that they're interested in. I know from my personal experience, I got into engineering because I love stereos, right? And this is not where my career ended up, but that's something that applies to like the high school level mind of thinking. Well, how do I do this? What types of products will I be working on? What types of things will I be touching on a day-to-day basis? What's cool, right? I think that applied, we call it applied, but that's the stuff that's really got some of these problem solvers and these technologists interested in even looking in the programs in the first place. I'd also try to appeal to the side that engineering technologists are great field service engineers, and this is a great growing aspect of technology business. To have service work in the field. These are people that like to be out, like to have their boots on, and really having a huge impact on the work that they do. So, and the only other differentiation point, I think the true engineering programs are the pathway to the master's and advanced degree levels, and if the student really knows at that time that they want an advanced degree, I think that's a major differentiator between the two programs.
Yeah, so just one last point on this, which is that, we can sort of define this as much as we like about practical versus more research and design and where they're going in the future. Kind of the bottom line on this, I would think, if I were asked that question, would be, let's look at the characteristics, the type of jobs, the type of work that graduates of our ET program are doing 5 years from now. Because that is, and there's a profile and there's a range, but if you can pick some characteristics of the graduates of your program and characteristics of engineering graduates, even at the same institution, it's like 5 years from now, these are the kinds of things, the jobs, the roles, the responsibilities, the locations even that you could be involved with So they're sort of the outcome that we're heading for. And the steps along the way over the next 2 to 4 years are steps towards that. But ultimately, 5 years from now, this is kind of a profile of what those two different, types of program graduates generally are doing. So which one of those is a better fit for you at this point? And that's what I'd say.
Okay. This is kind of a follow-on question. It's not mine, but it's one that has come up for me, and I'll read it. Frequently, you hear that ET students are more prepared initially because of that hands-on characteristic, and they become effective members of the team much more quickly than engineering graduates do. It's also sometimes the hearsay that at some future point, the careers of the engineering graduates become more successful in moving up in the chain. So the question is, what's your experience with that? Is that an accurate assessment or not?
My experience has been in the current state of ET graduates, that's not the case in terms of career progression. They're quite capable to move up the ladder as a pure engineering graduate would be. Early career, and I think that maybe goes to the legacy of the associate's ET degree, is that these ET graduates were maybe lab technicians, maybe the engineer's helper, right? And they tend to be very helpful, they tend to be very knowledgeable, and they tended to stay in the lab for a very long time and maybe not go up and progress through either engineering responsibility or management ranks. But I see it now as a very equal footing for the graduates. I think it depends on the individual. I would say the ET graduates tend to do better in that team environment that is the business place. I found with the engineers that I dealt with in the early leadership development programs that first team experience that they had was very foreign. So those of you that are familiar with GE's Edison Leadership Development Program, there's an A course which is very independent study based and very much familiar to the coursework in school that they have, very independent, very theoretical based. And then there's a B course, which is in their second year of employment, which is very team oriented. And I taught that team in systems design, and a lot of people struggled with how to work together in a team. And I think because I was dealing with purely engineering graduates is why I experienced a lot of struggle with those first team experiences, because it had to do with less theoretical, more conceptual, more systems design, and more application. And I think the ET, my experience is now that the ET graduates would actually fare better in those first couple years.
Yeah, so I think like most, sort of large workforces, you need a diversity of skills, right, to get the job done. I mean, that's an interesting point that Kyle was just making about the ability to work together in teams, to have an end goal in mind versus, sometimes we see this analysis paralysis characteristic, right, of sort of more, let me say, research-oriented types of graduates. Right, and I think you need a blend of the two. You don't always want to be rolling up your sleeves, charging the hill, taking that objective, right, whatever the objective is, without considering, the engineering alternatives, the cost, the maintainability, other aspects of the solution that you're building. On the other hand, you can study a problem to death, right, and research it to death, and, never get anything done. Just mention this because I happen to be having this problem as we speak back at the ranch. So maybe someone can help me with this.
You too.
So I think what you really need is a blend of people, a diversity of experiences, of styles, whether it's, sourced from technology graduates, engineering graduates, or not. But you always need this blend of styles and of experiences and approaches. I think that really helps to form a team that really is more effective than skewing one way or another.
Yeah, I agree with that 100%. And a problem is, though I have to say, I think anecdotally, I certainly have seen evidence of what you suggest. But the problem is that there's an underlying confounding factor that skews the problem, or even the question, which is that in my view, engineering technology is not as well respected as engineering. I think that's probably the majority view of this room. And I think that's a fundamental problem, that as a result, people aren't making the appropriate choice for their interests from the previous question, right? Of what's the appropriate, from my view, what's the appropriate mix of those knobs on science, engineering, technology? And so in many cases, I think the more promising, certainly the majority, we know the majority of students are tracked into engineering, some who would probably do better in an engineering technology program, and feel that that's where the prestige is, and then often are may be in fact more successful. And so I think that is actually an underlying problem that would be to all of our advantage to rectify.
Okay, thank you. I kind of suspected the next couple of questions. You mentioned graduate education for technology graduates. Turns out there are a few Master of Science and Technology programs already, and at least one PhD program. I'm just going to ask the question, and you'll have to figure out how to answer it.
I knew I was going to say something wrong while I was up here.
No, it's not right. It's just a developing field. And the question is, how would you see those graduates matching up with what you need at that level of education?
At the graduate level, at the graduate and engineering technology level. For the work that I do currently in operations engineering of large drives, there's not a whole lot of need for the more analysis-based or the more theoretical-based engineer. Now, I'll also say I have a parallel team that's in R&D, and they are doing the development work. They are doing the detailed level inverter control design, the detailed level control and electronics design, and I think that is a good fit, to be honest with you, in terms of if you look at somebody that does electronics design, for example. I managed an electronics design group for a couple years. That's a little bit of a magic. It's a little bit of hands-on. If you ever seen an electronics designer in the lab with the solder iron and trying to solder on a multi-pin processor, it comes with a steady hand as well, and I don't think I could do it because I'm not quite steady enough. So that mix of both the theoretical, to be a good electronics designer as well, you have to be very, very oriented in the fundamentals of those design techniques, and that's something that our R&D group does do every day. So I think when I think of that degree, I think electronics design, because when my experience was designing embedded controllers for locomotives, that's exactly what those guys did. They were behind a screen for half the day, doing layouts, doing timing analysis, selecting components, and they were also in the lab the other half of the day, hopefully into the night, doing the soldering and doing the applied and doing the testing. So I think that would make an excellent fit. It's just from what we do, from customer order taking and producing, I don't think it would challenge them enough on the design aspect.
Anybody else want to take a shot at it?
Yeah, I'm a little biased because I think, my degrees were in electrical engineering and mechanical engineering and computer science as I went through my bachelor's, master's, and PhD. And I work on robotics, which is housed academically. It's housed in any of those departments, plus aeronautical engineering, plus industrial engineering. It's scattered all over the place. Why? Because it's an interdisciplinary field. And again, if you go back to that definition that I have in my head, at least, for what is technology, it's the implementation of new solutions, right? Solutions are intrinsically more, I like the word transdisciplinary, interdisciplinary if you want. And I think that is where our science and technology are actually heading, is to a more interdisciplinary programs. Again, because the whole STEM pie is growing, not because the traditional siloed divisions are getting less important. It's because everything is becoming STEM, right, or becoming STEM related, and so we're getting all these other things. We talked about CS Plus when I was in the CS department, bioinformatics and all these other things. And so I think that is actually a very relevant point for engineering technology and the value of of the education is that it involves to focus on solutions. You have to be involved in much more than just your silo, right? You have to be willing to expand and at least embrace these other parts and the contributions other people can make. And so I think it's actually very important.
Okay. Changing directions completely. You're probably all aware of the fact that the U.S. News and World Report does a college ranking every year. As of today, that ranking doesn't single out engineering technology programs. The question that was asked is, what do you think about the idea of trying to encourage some kind of ranking of ET programs in this country? Would it be valuable or not? I told you it was off the wall. Right, Walt?
So the programs are excluded completely from the survey?
I don't know that we know the data, but there's nothing in the call out of the results that singles out engineering technology. Whether they somehow include that in some other ranking is, to my knowledge, not clear from the information that's published.
Right. So, I mean, as an employer, we don't spend much time looking at the rankings. I can imagine, college applicants do look at the rankings when they make choices among schools, assuming they have the ability to make choices. As an employer, we don't really use the rankings. We have choices to make about things like campus recruiting, where we invest our dollars, right, to send recruiting teams to campus. So we're going to send, recruiters to where we feel we'll get the largest and strongest students. But there are obviously other recruiting mechanisms we have besides college recruiting. Job fairs are held, e-recruiting events, jobs are posted online, things like that. And we accept applicants from all. So, for me, it would have, probably less benefit than potentially it might for the students who have to make a decision about, where to spend their educational dollars.
I think an important aspect of that or an important strength of the engineering technology programs is that we do span the associate's degree, the bachelor's degree, and graduate degrees. I think that is a scalable aspect that when I talk about that pyramid of design to implementation, I think that mirrors that actually more strongly than engineering does. But that creates a rankings problem, right? Because right now the majority of our programs are associate's degree programs, and you can't compare an associate program to a bachelor's program directly. I think that is a weakness in our system. I think we need more bachelors of engineering technology or equivalent, and then it would make more sense to rank and rank the entire spectrum.
You heard it here first, people. This question is about some comments in earlier sessions. There was some talk about industry supporting the universities in the preparation of desired graduates. There was also discussion about the Industrial Advisory Board and their influence on those kind of things. So the question is, at your company, is there anything you're doing that is helping universities, or are there some things you could think about that you might be able to do to help us along those lines? And I guess one aspect of that I'll add to this, I suspect it is true that most of our industrial advisory boards are like mine, and they're populated to a great extent by former graduates. So the question becomes, is there a way that we could encourage industry people not familiar with our programs and graduates to come in and help us? What kind of message would it take to go to them that would convince them to spend some time 2 or 3 times a year?
Mm-hmm. Specific to the question, yes, Siemens is investing in universities, and there was a large gift recently of the tools that Siemens provides in Team Center and PLM being gifted to Penn State, and I'm sure there's been many more that haven't made as much of the headlines of that. I think what's more important on these advisory boards, though, is that local connection that I spoke of earlier. Many of these large corporations, they don't exist in thousands of people in one single location in most instances. Mostly they're distributed locations around the globe of a couple hundred people in some medium-sized facilities. And what I've found through my experience is that the key industry connection to education is those local relationships, because typically, and especially in manufacturing, the places where these factories are located are somewhat remote. Maybe not remote, but at least not in urban centers or directly in an urban center where there's a huge population of talent available, right? So what's been really important in my career is to develop local talent that want to stay in these locations, want to develop in these local communities. And to me, moving forward, that's where I intend to focus my efforts as a leader within the company.
Yeah, so I mentioned this one program earlier, which is, a significant investment both by, our company and by, the college and the city of New York. So it takes money, it takes effort, and that's not always easy to ask. So our company, besides things like that, obviously we're involved in, sponsoring internships and co-op programs and things of that nature at a wide variety of schools. But, I agree with this comment from Kyle about local involvement. Because, that's really where, I think I read a statistic one time, so maybe I'm making this up, but bear with me, that students, 75% of students settle within a radius, I think it was a 50-mile radius of where they go to college, right? And that's true regardless of whether it's technology or engineering or other disciplines. So generally, I mean, having local involvement by companies and by other enterprises nearby is really important. And graduates are good, so that maintains some involvement. Clearly, this is not one size fits all, because you could get representatives from different companies that have different needs of graduates, that have different priorities of the graduates, and perhaps get a little bit of a tension in the advice they're providing to the program. But nurturing, in my mind, nurturing that relationship is really important.
It's hard to figure out what hat to answer that question with, but clearly the federal government is investing, I think, a lot in universities. But one of the things that I was constantly trying to do it when I was at either both NSF and OSTP, although more so at OSTP, is public-private partnerships, which I think are really important. I think they've waned more so than they really need to. And in fact, just yesterday I was giving a talk on productive public-private partnerships, 4 Ps instead of 3 Ps. But I do think it is a difficult model, particularly in this political environment where our discretionary dollars are shrinking, and we have these entrenched camps that represent kind of opposite ends of the spectrum of politically of what the government can do, and trying to encourage both business and academia to work together with shrinking discretionary dollars is harder and harder, but I think is becoming more and more critical, right? Because there are these big societal problems that do require solutions that come from a broad spectrum, and I think this is really an important aspect of moving forward and being productive.
Okay. I suspect, Richard, this is probably for you, although all of you may have an answer. It seems clear from your comments that industry in general, at least the industry that is aware of engineering technology graduates and what they can do, has a much clearer idea of what the distinctions are and what the value of each group is. The question here is, as the government representative, what can we do to help the government recognize those same aspects? Because it's currently formulated, it doesn't.
I think that's true. As currently formulated, and that I think is part of why I've been invited back, right, it is because when I talk to people about these problems within the government, everyone says, Yeah, oh yeah, I get it. Yeah, that really, I really understand what you mean. At the same time, I run into opposition at times at the policy level, right? So it's not at the ideological level where everyone says, yep, I get it, this makes sense. But the way government operates, right now there's such a big gulf, right, between what I'm kind of proposing what it should be, or what I think people are kind of saying, oh yeah, I kind of see that, and where we are right now. And one of the things is look at the enrollments, right, of engineering technology and engineering. Is engineering technology even significant, right? You could make that argument from the enrollment perspective. Yet when you explain what the potential is, I think everyone says yes. And so it's a question of baby steps, because that's the way the government operates. And while everyone can see the big picture, right, and say, and I get a lot of support for the big picture, but then it becomes, oh, but gee, how practically do you implement that? And it's a question of patience, and the impact that one person can have on the federal government is amazingly large. And so that extends also to everyone in this room. The impact of things, I see the impact, tremendous impacts of what individuals do, right, in their daily lives, in their professions, in moving the needle in this direction. And so I think from that standpoint, I think it's great. We do, as a community, have to take just a bunch of these baby steps and keep moving toward this mission. And I think that we can be successful.
Okay. Either one of you, any other thoughts? Let me check the time here. I know we want to. Okay. This is a question. Certainly I'm not familiar with the details of this, but the question is it possible to replicate the medical industry model in which a BSET graduates are general engineering practitioners and a BS degree engineering graduate or graduates with some specific specialty in engineering beyond being able to function as a general engineering practitioner? Is that a possible thing to replicate? Is it something we might want to do even, I guess, as a...
From a hiring perspective, I would say I do struggle with engineering graduates and understanding where their specialties are. So
we had that discussion.
Yeah. I mean, I was just doing some recruiting just recently, and I was talking to second year sophomores, maybe junior year, for internships, and it was very hard if they haven't had previous internship experience to figure out who I was really interested in, because they all had the same classwork background. They had very little exposure into what type of discipline they were interested in, or if my type of work in power conversion and controls was something that they really wanted to do long term. And especially when you're hiring at the intern level, you're looking for your immediate needs, but you're equally looking for the student needs and giving the student an experience to be able to take away with them that's going to be relevant to the rest of their career. So I don't know if it's possible or not, but I think that the same with the certifications that you mentioned. I think there's a potential advantage in it.
Yeah, I mean, I think that would be quite a sea change, right? Because I'm just thinking about it, the medical profession. I don't know that much about it, but seems like someone who becomes a specialist, it's not clear that they start out on day one of med school, or even in their bachelor's studies, knowing that someday they want to be a heart surgeon or urologist or whatever. That's something I would think that evolves as they learn more about the possibilities within the medical profession. And they do a little of each and then decide which one makes the most sense for them. That could be wrong, but that's sort of the way I see it. There are some external models, right, because perhaps they've dealt with medical professionals in these various disciplines. So then I think about engineering and exactly what specialty. I mean, it's hard enough sometimes, as was just said, without really experiencing life on the job until you graduate to really understand what your choices could be. So specializing and sort of tracking your way through that before you really have enough basis to understand what where your interests really lie long term, I think that would be difficult, actually. And again, I mean, we often will hire graduates with skills, with certification, and then with capabilities, right? To learn, to work with others, to grow, to advance their career however they decide to advance it through a combination of self-directed activities and support from the company, right? In rotating assignments and in formal training and things of that nature. So it sort of evolves over time rather than starting out as, this is my specialty and my track, and that's where I'm headed the rest of my engineering career.
I think there's a, so I deal with robotics and artificial intelligence, and maybe this is tainted by that view, which is that biological evolution is very slow. Technological evolution is very fast. And we do have a breadth of basic knowledge that we get, I think, in both programs in engineering and engineering technology. But I think with the pace of technological evolution, our brains, and what I mean by that is our brains are fixed, right? For the next 20,000 years, our brains aren't going to change much. In the next 20,000 minutes, we're going to see enormous progress in technological innovation. And I think that that conundrum, right, means that the need to specialize actually is growing. And yeah, we have to have a good, broad foundation. But at the same time, I don't like that separation of saying, oh, okay, ET is more of a general engineering, and then you have these specialties, because I think that happens over time in all these fields, right? Is that in order to keep pace as technological, and the implications there is not that we can master all of it, is that we have a limited amount of capacity, humans do, relative to the broadening scope of technology. And so that amount is finite. We have to keep it going at the leading edge. And so what that would imply, if we adopted that position, I think, for engineering technology, I think it would be becoming just less and less important. Right, is because we would still be using slide rules, and we would still be using, which is what we've done, right, to get past that, is we focused on the tools and technology as it advanced. So I don't actually like that idea.
Okay. I think we have time for one more question, and I have two, so I have to choose here. So let me try this one. Something that's being done more and more places is putting together portfolios for graduates. And so the question here is, if a graduate had 120 competencies on their transcripts with an e-portfolio that better describes their skill sets, rather than just a list of 40 courses, would that be a more valuable thing for you guys to see in recruiting or not?
So it would be a lot more valuable for me, because often in the process, how do we bring in graduates? So, we can do this through campus recruiting and in-person discussions, right? Someone sits there with a resume and they start to scan it. But often the way it works is there's an e-recruiting job site that we maintain, and a portal for applicants to put in their resume. So what happens when they do that? Well, it starts with sometimes keyword matches, right? Keywords in the resume, keywords in the jobs that we are hiring for. And that can be the first pass at trying to select, who will make it to the next stage of the process, right? To speak to some human being that generally would start out with HR and then progress from there. So, for me at least, having not just a long list of keywords that are going to match something, right? I mean, that by itself is not necessarily helpful, but that are backed up by experiences that when we finally get to the stage of interviewing a candidate, and we see this list, maybe it's not 120, but the list of things that they're really good at, and then we can start to ask them about it. You know, tell us your experience in working with technology X or tool Y or the knowledge you have here and there. Where have you applied it? Tell us about a project in your class. Tell us about an assignment that you did with your classmates, a capstone experience, an internship, a co-op experience, something where, demonstrate that it's not just a word on a piece of paper, but it really is a competency that they have and that they can demonstrate and that they can communicate effectively, right? It's one thing to have a skill, and maybe you really do have it, but without being able to effectively communicate it to us, it's going to be hard to understand why that's a valuable hire. So from my perspective, yes, that would be more useful.
Second that. It's the experiences that I'm looking for on a resume. It's if you think over our lunchtime session, I look at the technology as the fundamental, and I again, the way I get to that is I ask about what were your experiences with the technology, and can you really explain to me what your involvement was, what your contribution was, what your understanding was of what you were assigned to do in these types of things. Then on the cultural, I look for the candidates that stick out. I look for the ones that have those intercultural experiences, and what did you learn? What did you take away from it? How are you a different person now that you've gone through those types of things? So without going on, I mean, to me, it's the experiences.
Okay.
Well put.
Okay. All right, one last, any final comments that any of you would like to make? If not, can we give them a big round of applause? Pat, are you coming up, or you want me to make? Okay. Pat has a few last-minute pieces of information. Thank you, gentlemen.
I wanted to formally thank all of you guys again for coming. This isn't totally over with. We still have dinner tonight. But as last words, thanks again for coming. I want to thank all of our panelists, including you guys, for participating. We really appreciate it. I want to thank the moderators for doing such an excellent job, and also the program committee, because this was a year-long process to put this program together. So all of those people who helped with the program, I really appreciate that as well. The dinner tonight is at 6. It's in the same room that we had lunch. And we're going to have wine. And with that wine, we're going to put you to work a little bit, informally, let's say. And we're going, no ties, just wear your jeans if you want. It's fine. We're going to talk about whatever you really want to talk about, maybe further discussion about what we talked about today. Give us some ideas for topics for next year. Whatever. So you're free for an hour, but come back and have dinner with us, and it'll be fun. Thank you.
All right.